Okay, we should be recording and we can see everything. Cool. So how did the thing last week go, the workflow with the shortest walk? I know we had some issues, but I hope we solved all of them. Yeah. For today's class, since we didn't have class last week, I put two workflows together. They're not that big, so they should fit in today's class just fine. Cool. The first one we'll take a look at uses the Pufferfish plugin and the Twisted Box workflow. Let me change this just a little bit. So we'll use that to create some repeating patterns that are quite organic like this. They're also using the Mesh Plus plugin. I'll get better down there. To make these interesting patterns. So we'll focus on like a necklace form for this, and we should be able to use that AR base form that you have in both the Rhino and the Grasshopper file. In the Rhino file that I had, the little base form is a lot smaller. In the Grasshopper, it's massive. I'll explain quickly. This base form is different than the one we used last week. This one is useful if you're doing any augmented reality work. So with the Snapchat toolbox that they created for AR work, you can use this figure for some body tracking stuff. So I just figured I'd provide a couple of different like base meshes for use in different scenarios. The one we did last week would be more for rendering high-res images. This figurine today is a lot more low resolution. And then the second workflow that we'll take a look at, scroll down here, is this surface texture workflow. So taking a base surface from that you can design in Rhino with a loft or just with some of the surfacing tools. We can take that and apply a pattern to it that you can change based on the movement of an attractor point. So kind of combining some of the workflows from the past weeks with some new tools and new plugins. And this will be using the Lunchbox with a couple other plugins for some simple things as well. But the main pattern on the surface here, that diamond cell pattern, is with the Lunchbox plugin. So with those two, we'll take a look at the necklace workflow first. No, you're good. Yeah, so with the Rhino file that you should have open, there's 3 layers here, and I don't think I set them when I sent you the file, but basically there's just the main mesh figure, the curves around the neck, and then the surface, which should be on the floor, which we'll take a look at that in the second half of the workflow. But for right now, we just want the figure and the curves, and we'll use those two for this first one. I provided you all the curves so we can move quicker through the workflow, but you can easily edit the curves to be your own shape, to make your own form, just like we've done in previous classes where you can change the inputs to get a different look. So let me create a new file here. Okay, so with this workflow, creating a twisted box, basically what's happening is I'll try to explain the twisted box methodology before we start building out the script. But what this does is basically using the curves that I have in the scene, we can create sort of like a pipe that you would use in Rhino normally, or basically a pipe with 4 sides, and we can divide that pipe up into segments. We can take a base geometry and morph that into the geometry of the twisted box itself. And then with those multiple segments, we can utilize that pattern across the entire length of the twisted box, and then merge that together with some of the scripting and Dendra that we've done in the past to make a fully 3D printable mesh that we can bake out into Rhino and export. So with the twisted box in the Pufferfish plugin, I'll just find that so we can see everything that's possible in there. So with Pufferfish, we have all these toolboxes or toolbars up top, these drop downs, but the one we'll be focusing on the most today is the twisted box drop down. There's a lot of stuff in here, but we'll only be using one of the components today. There's a lot of different ways to create twisted boxes, and you would use this anytime you want to apply a pattern to either a volume or a surface that's not super planar. So it could be a very organic surface, but if we can divide it into multiple boxes, we can apply the pattern into those boxes to give us a more interesting shape or infill type or something like that. So you can see we can create twisted boxes in tubes. We can create them in simple linear arrays. We can create them around meshes, curves, and all that. But today we'll just be doing a twisted box sweep. Let me see. Where is that? There's so many things here. Yeah, so this one. So we can see the description here is you can create a twisted box along 4 rail curves and then dividing the domain of those curves into multiple segments. So that's pretty useful with the Rhino file that we have. We have 4 curves in here that kind of make up the bounds of a 4-sided rectangle swept along this path. So the rectangle is never consistent. It's always changing and moving in size. And if we look back at the pattern up here, we can see that those edges are kept. So we have like 1 edge, 2 edge, and then 3, and then 4 on the other side. And then that pattern you see is repeated along the sweep that we're doing with those curves.
Let's see real quick.
Yeah.
So in my layers tab in Rhino, I'm only seeing the default layer and not like those alternative curve layers.
Okay. It might not have come across when I showed the file, but
Okay.
I mean, there's not much to it. I was just trying to divide the mesh from the curves. So you could do that yourself too. And if you've never worked in Rhino, I can show basically how that would be accomplished. So I believe the scene that you have probably looks like this with all the things populating the scene. So we have the surface at the bottom, the mesh figure in the middle, and then the curves around their neck for the necklace.
Mine just looks like this.
Oh, have you opened up the Rhino file? So that should be the Grasshopper file, just has the figure in it.
No. Oh, never mind. Here we go. I got
Okay.
it. Yep. Awesome. Thanks.
Yeah. But I mean, I still believe that the different segments are not actually on the layers. I think I forgot to set them. So for anyone that hasn't worked in Rhino specifically for changing layers, I'll go through that pretty quickly of how you can like divide up your scene into multiple layers so it's easier to work with. And that'll help us take away the figures so we can just focus on the curves for some of the initial setup. So yeah, in Rhino, I'm just going to hide the curve first since that's not part of this first workflow. And the way we can do that, I have all the tabs on the side, but in order to put a piece of geometry, a curve, a point, whatever into a different layer, what we can do is click on the thing or the multiple things we want to put in that layer. And right now I want to put the surface in the surface layer. So if we right click on the surface layer, we'll have this drop down. And there's this one option here called change object layer. And that'll take the object in Rhino and it'll change that from the layer it's on, which at this point is the default layer. And it'll change that to the surface layer.
Okay.
So I can hit change, nothing will happen visually, but it's on that layer now. So if I was to click the little light bulb in the surface layer, we'll see that the layer will hide away from itself. So we can organize our Rhino file like that. So we have these in layers that we can show and hide, kind of like Photoshop. Makes it a little bit easier. And we can do the same thing for the figurine. So we can change that object to the figure layer, hide that away, and then we're left with just the curves.
Wait, sorry, let me just stop you. Question about this. So I'm opening up the Grasshopper file, it opens up this Rhino file, but then when I open the other Rhino file separately, are these supposed to be 2 different files?
Yeah, so the Grasshopper file that I shared just has 1 component in it, and then the Rhino file has the 3 pieces of geometry, and that's all that I had shared.
Okay.
Yeah. So I'm going to start from the new Grasshopper file from scratch with nothing in it.
Okay.
So as long as you have the Rhino file open, we should be good to go. Yep. Okay, so with the base mesh and the curves, the first thing that we can do, I've already given you the curves, so we don't have to build them and spend 10 minutes building the curves, is right now they're all around the neck, but they're not really on top of it. A couple of them are going through the neck, and we want them to be on the outside so we don't have any clipping issues with the geometry and the figure in the scene. So I've touched on this briefly in, I think, the first class, but to look at it again, with the curves in the Rhino scene, we still have editing control over these curves with the control points placed around the curve. So if we click on the curve, we can see that we have all these control points. And if we want to move them away, we can just simply grab the gumball tool and move it out like that. Let me move this real quick. If you don't see the gumball, there's a button down at the bottom that can show and hide the gumball. And that's just the little arrows in the rotating tools so we can move things around. Also, tip for the gumball, you can right click it and it has a lot more settings in here. So a couple settings that I like is by default, it's set to align to the grid in your scene, but you can also set it to align to the object itself. So now the blue handle is going to be kind of the normal of the curve. So we can move it in and out based on the directionality of the curve. You can also do this for surfaces and things like that if you want a little bit more directional control, but I'll just keep it in the base coordinates of the Rhino file itself. So we'll see the curve right here is clipping through the neck a little bit, and we'll want to pull it away, but we'll notice the curve right there is hidden underneath the mesh. Which means it might be hard to click because we might click on the mesh of the person itself, which we don't want to do. We only want to edit the curves at this moment and not worry about the mesh. The mesh right now is just a reference so we can model around it, but we don't want to make any changes to it. So in order to get rid of the issue of us clicking on the mesh instead of the curves, right next to the little light bulb is another button. That's just the lock, so we can lock and unlock a layer. So if I was to lock the figure layer, now if I click on it, I can't actually select the figure, which is super nice because now the only thing we can click in the scene is the curves, which is what I want to edit. So now we can come and grab that control point, which is inside the mesh, and we won't have the issue of clicking one or the other. We can just click on that point. And now we can go through and pull the curve out to whatever length you want to surround the neck.
Where did you say the locking was?
So right next to the light bulb in the layer panel, there's a little padlock button. So if you have your mesh figure set to the figure layer and you lock that layer, you won't be able to click on the mesh anymore. Yeah. So I'll do that for one curve, but we'll basically want to do the same thing for all the curves. We don't have to at this point because we'll still get a model out of this, but it'll be clipping through the mesh. So I'll just go in and quickly pull some of these points away. Doesn't have to be anything nice. We can go back and change this later after we build the script. But I'll just pull the curves out a little bit and I'll give you all a minute or so to go move the points to your liking. Yeah. But it'd be the curves? Yeah. Oh yeah. So did you open up the Rhino file that I had sent?
Yeah, that's right.
Okay. If we check here the layer tab without any curves. So grasshopper. Yeah. Yeah, so what I'm seeing in the scene now is just that figure from the component grasshopper. In Rhino, if you go to open a new file, it should be just everything on it. Yeah, so in the Discord, I had two files under the. Yeah, yeah. So that's the grasshopper one, the blue. So we'll want to download the Rhino one.
Sure.
Open that, and the curve should all be there. Yeah. Okay, so the curves don't have to be perfect at this point, but if we have 4 curves, that's all we really need at this moment. And we'll go ahead and build out the script in Grasshopper now. So a lot of these workflows, most of the work in Rhino is pretty simple. And when we move into Grasshopper, that's when the shapes and forms will get a little bit more complex. So yeah, if you've been following along in some of the past classes, whenever we work in Rhino, we always internalize the data from Rhino to Grasshopper. So right now, since we're working with the curves, I'm just gonna go ahead and hide the figure. We don't need that at the moment. But now that we have 4 curves, we'll put these all in Grasshopper. So as we've done in the past, we can pull out one of these input components, such as the curve that holds curves in Grasshopper. And we'll pull out 4 of these. So I'll just copy and paste. Susan's already miles ahead. So once we get 4 out, we'll set these curves into the component curves in Grasshopper itself. One thing that might matter when we're actually adding the twisted box is we want the curves to flow in order, like either clockwise or counterclockwise, like around the way they've been placed. So if this is the first one we set, we'll either want to set this one or this one next. So we'll want to go 1. And if you see a little bit more 3D here, I want to go 2, 3, 4, and make sure it's a smooth like loop around the shape. If we go like 1, 2, and then 3 and 4, the sweep will not be a closed like circle around the 4 curves. So we want to make sure we select them and put them into the curves in a logical order. So I'll take the first one here, and right-clicking on the first curve component, we can go and set one curve, which will set the curve that we've clicked on in Rhino into the component in Grasshopper. And the component should now show up as gray. So I'll do the same thing for the next one. I'll click on the curve, right-click the component, and set the curve into that component. I'll just do that for the 3rd and the 4th one as well. Okay, so once we've done that, we should be able to click through and see them show up green. So we can see 1, 2, 3, and 4 going around the curves that we set. Yeah, question.
I'm kind of a problem where like it's not recognizing different curves and it's not assigning them to the grasshopper box.
Okay, yeah, when it comes to it, part is the way that you're selecting things. So, yeah, you go ahead and set the curve in that one. Seems like it should work fine. And then you want to make sure you're going in order. So if that was the 3rd one should be on the side and then the 4th to the top. It'll just matter later on how you're setting these.
Like I said, I should go back to.
You don't have to redo the first two, just that third one I noticed was the top one. So we'll want to go around the shape. So if you did the left one, then the bottom one, then you do the right one, and then the top one.
Okay.
Yeah, and this will become clear as we add the next component in the scene. So if anyone set them incorrectly, will be a visual issue. But I think, yeah, everything looks like, you know, any issue now. So good.
Yeah. Right to last, I don't like to walk along.
Yeah, I'll come look in a minute. Okay, so if you double click on the perspective button. And then if you pull up your layers panel, that will like red button. And you didn't overwrite it or anything. Just from
I'm just looking.
okay. Yeah, I mean, maybe you try opening the top one there. If you double click, it will open a new Rhino instance. So usually, if you go in the Rhino, you would open, just go open from there.
Yeah.
Yeah, but yeah, if it's still nothing showing up, I would just re-download it from Discord again. And then go into Rhino and do file open the file you just downloaded, and it should be there. Yeah, what's the question?
What do you mean by like right to left?
Yeah, so there's four curves kind of going around in a circle. So you have like the first, second, third, and fourth, and going like bottom, right, top, and left. It'll become clear as we have the next component if there's like an issue with how it's sorting. And I think I'll explain it better when we look at that.
That's like 1, 2, 3, 4.
Yeah, so if there's like a curve on the bottom, so going first, and if there's a curve on the outside of the shape, so that next one, the top one, and then the inner curves, so kind of like moving around, if you're not jumping back and forth. But yeah, I'll visualize with the next component what I mean. I'll do it the incorrect way, and we'll see what the sweep looks like, or the loft looks like, versus if you inputted them correctly, what that'll look like. So the next component, as I mentioned, is the twisted box sweep. It should be right here. So we can look this up as twisted box sweep, or you can find it in the Pufferfish twisted box dropdown. And with this component, we'll notice it has these 4 rail curves that it needs, which are the ones we just set. So rails 1, 2, 3, and 4. So I have these here. So I'll go ahead and plug them in as 1, 2, 3, and 4. But as I set them, I set the inner, the top, the outer curve, and then the bottom curve. So if I plug them in the wrong order, we'll see that the twisted box goes up, and then it goes to the bottom, and then it goes out, and then it goes through itself. So if I was to set it in an order flowing around the outside, we'll see that now we have a line going up here. So we know it's wrapping as like a skin tight mesh around the 4 curves rather than going through itself from opposite curve to opposite curve.
My plugin keeps
Disappearing.
like it shows up and then it just crashed and then disappears.
Like the plugin itself crashes, or Grasshopper crashes?
The whole thing. I try to do something from fish and Rhino, Grasshopper, everything closed out.
Interesting. I haven't seen that issue before, but I mean, I would assume maybe when you installed the plugin, everything wasn't moved into the folder, or wasn't all unblocked, so it doesn't have something it needs to run. That's what my assumption would be. Yeah. Yeah, so I'm gonna pull up an actual loft component because that'll show us like a surface that we can see a little bit better. And I'll go ahead and plug these in in that same order I did before. Let me just delete this for a second. Okay, so with this one, I've put the curves in a little mixed up, so the third and the fourth are switched. So we can see with this one, I'm starting with the first curve, which is highlighted in green here. And we can see with the loft, as well as the curve, we go from curve on the inner to the upper curve, so we can see the loft is flowing up. And then what I'm looking for this script in particular, which if you're making your own script, you can plug it in however you want, but just for this one, since we want a solid like internal structure, we want this whole thing to be like a skin tight mesh around it. So we can see that the loft going from the second curve to the fourth curve goes down here to this curve, and then it goes out to this one. And if we were to close this loft off, we'll see that the surface then comes back through to this first line over here. So we have this like intersection of the surfaces. If I was to plug the third one into third and fourth into fourth, we'll now see that it comes from the first curve up to the second, and then smoothly around to the third, and then back under to the fourth. So we have this kind of like inflated form going around it with the loft, just to show what I mean when I input. And you can see from the end here as well too, kind of this clockwise, counterclockwise, one or the other inputs, where we start over here on the right, come over here up a little bit, and then down to the bottom, and then the fourth one. So kind of going in a smooth circle between all the curves. Yeah.
You're popping up on my loft box,
On your twisted box?
the loft.
Oh, you pulled in the loft component. What's it saying?
No profile curve will move. Box to curve.
Oh, okay. So I have a merge component right there. And with what the merge does is it basically just pulls a couple pieces of data in the same set. So I pulled the loft in just to visualize this question. We won't actually be using it, so we're just using the twisted box. So it looks like yours is set up correctly because we get the lines kind of going around the whole shape and not through the shape. Okay. So should we see what I did wrong? I can try, but I know there's a lot of components in Pufferfish. And you're running in a Mac operating system, which should be fine for Pufferfish. But I mean, I wouldn't. So that's the libraries, and the other one is the download folder. So did you put that green component in Grasshopper as well? That should be in the components folder. Okay, and that's stuff that you drop down. Okay, yeah, no, that looks fine. And if you have the file in special folders, go down to the user objects. So you'll need to put those GH user files into this folder, the user object folder. So take it out. Yeah, take out components and put it in the user object. Yeah. And then you should be good. That was. Okay. Okay, so I'm going back to the twisted box sweep, which you should all already be at. So we'll get that kind of box shaped structure there. Okay, so we've applied the 4 curves, and nothing's going to crash if you put the curves in the wrong place, but it'll just look slightly different than mine. But right now we do have the lines wrapping around the entire form and not going through it. So right now we should be good. The next input for this one is the parameters, and this value will set how many sections we have in this twisted box. So right now we have around 16 segments, but we can change that pretty easily with a slider. So I'll grab a slider and you can set it to whatever range you want. I'll put the lowest bound at 2, just so we have at least 2 cells, and I'll go up to 30 or something, but you can have a slider as big or small as you want. So with this slider, with whatever number you put it on, plugging it into T is not going to do anything at the moment. If we hover over the T parameter on the twisted box, we'll see that the data actually populating this input goes from 0 to 1 with a lot of decimal places in between. So what this is doing, and this is the same thing if you're analyzing a curve or something, if you want to evaluate it, we have that same input, this lowercase t right here, which is the parameters. What the parameters is actually saying is it's taking the sweep we have starting from 0, which we could say is one of the ends, going all the way around to a number of 1, which will be the end of the sweep. And we can divide 0 to 1 into as many decimal places as we like in between. And for each of those decimals, it's going to add another ending to a segment. So we have from 0 to 0.06 over here, and that's just one single segment. And then going around, we have all the rest of the numbers. So with this slider, what we can do to get this same list of data, which are all these decimals, is we can use a range component. And what the range will do is it'll take the number from the slider and it'll divide the domain of 0 to 1 up into all those decimals. So right now, the input for the domain by default is 0 to 1, which is the most useful because a lot of the curves that we'll be working with always have a domain of 0 to 1, or you can reparameterize it to have a domain of 0 to 1. So the D input is fine as it is. The N input is the number of steps, and that'll just be the slider that we just brought into the scene. And this will change the range, and with the panel, we can see exactly what it's outputting as we change it. So right now with 2 steps, we have 3 numbers, but 2 different steps from 0 up to 1. And as we change this number, this list will grow. And it'll grow to a set of numbers 1 bigger than the number we set, but with decimal places that update to have an even distribution between 0 and 1. So with that range, we can plug that into the lowercase t value. And as we change that, we can see that the parameter of the twisted boxes inside of this sweep will grow and shrink as we change that slider. The closer we are to 0, the less high quality the sweep will be, as it has less numbers to work with. And the higher we go up, the more closely the twisted box is going to approximate the shape of the sweep from the curves that we input originally. So we can set this to whatever number we like. So with the next step here, once we have the twisted box set up, we basically have the lattice structure for the geometry that we want to apply into this. One component we can use to orient our geometry and morph it into the twisted boxes is to use a component called morph to twisted box. And this does pretty much what it says. It'll use the twisted box that we just created, as well as another piece of geometry. And with that geometry and a boundary region for that geometry, it'll take that box and morph it into the new boxes we just created. The box is basically just a super basic boundary of a region in space. And whatever we put within that region, we can morph that to a new box. So kind of pull the vertices and the lines of a piece of mesh to a new shape, to a new box. So I'll grab that component. With this component, it needs the twisted boxes at the bottom here, which we have set up. So we can go ahead and plug that in. The next thing we'll do here is actually get the mesh that we want to morph into the boxes. We could do something super simple, and we could grab, say, a simple center box, which will just place a box at the origin of the Rhino scene. This is the simplest piece of geometry you could use, but I'll pull out something a little more complex in a second so we can see a more high detail model. But just to explain like what's going to happen going from this box down here to something actually populating the structure of this twisted box is to show it with something simple first. So we'll use this box, and the morph to twisted box component is asking for a piece of geometry in G, which we can use as the box or whatever we substitute for the box. And it also needs a region or a reference to morph from. So that'll just be the original box itself. So right now, since we might change this in the future, I want a better way for approximating the box region around this input geometry. So something really useful that you'll probably use a lot in Grasshopper is a bounding box. And a bounding box can take any piece of geometry, curve, mesh, sub-D, B-rep, what have you, and it'll place a box oriented on the XY plane around whatever piece of geometry you feed into it. We can change the plane, but for now we'll keep it just at the XY. So with this bounding box, it asks for any kind of content. So we'll use that box as the content. And if we place that in the input for the bounding box, you see we'll get another box that fully encompasses the original box. Right now, this isn't going to look any different than the box, but when we change the geometry, we'll see that this box will now be approximating something more complex inside of it. But we'll set this up for better workflow down the road. So now we have the original geometry that the morph to twisted box wants, and we also have the region surrounding that original piece of geometry. So we can plug the geometry in, and we can plug the bounding box in as well to the region. So when that happens, we'll notice that the boxes will be taken from the ground and applied into the lattice structure of the twisted box we have. Basically, right now, it's just filling in the boxes that were already there with a B-rep in its place. And it'll be giving us, in this case, my case, 17 closed B-reps morphed to the new region of the twisted box.
Sorry, can
Yeah.
you explain again, like, why do we do the boundary for reference in the geometry?
Right, so for this workflow as it stands, we could use the box as its own
yeah.
reference.
Okay.
But if I was to have something more complex, like if I was to add a sphere into the scene, the sphere is not in itself a box. So if I was to replace these inputs with the sphere, then we'll have the sphere and we'll have the box completely surrounding the sphere. And then as we go up to the morph to box, we'll see that now the spheres have been kind of crushed and morphed into the twisted box itself. But we need this reference to morph from.
Okay.
It needs something to go from, and then we have
So
the box
is
too.
like the boundary button is like to create a boundary, so
Mhm.
like it has to have that boundary
Right.
for the reference.
Yeah, it's basically taking this original bounding box
Mhm.
and it's saying like, where is it? Like this vertice right
Mhm.
here is now
It goes
being
up.
pulled up here to this vertice,
Okay.
and it changes the sphere with it as it pulls it.
Oh, okay.
Yeah.
So we can just do the sphere itself, because it will.
Right, yeah, the sphere itself is not a region. I can try it. I don't think it'll do anything weird. Okay, it worked, but that goes not to my point, because we could have something even more complex. Like
Okay.
I'm gonna do a mesh in a second here,
Okay.
which this workflow will be able to just switch out the input mesh
Mhm.
and everything else should flow along. But
It applies on like this kind of complex form.
right, I would say the bounding box is like a pretty good way to work if you're trying to keep things light. Because the bounding box itself is only made up of 6 faces.
Mhm.
Whereas if we had a mesh with like 1,000 vertices, using that as its own reference would be super heavy, where we could just throw a box around it and then use that for moving and things like that. So
Is it kind of like the cage tool? I don't know. It's like creating like kind of like a cage.
it sounds similar.
And like
Yeah.
the control points and like pull it into the shape.
Okay, yeah, if you can have a more complex cage, for sure. Yeah, definitely like that. Kind of just a tool to help morphing. If you've ever used the orient tool as well in Grasshopper,
Mhm.
where you go from an original plane to a target plane,
Mhm.
it's like the same thing, but in 3 dimensions here. So, okay, we'll use the mesh plus component now, which should be right here. And instead of creating my own complex mesh that I morph into the twisted box, the mesh plus plugin has these really interesting shapes that just come with it. So we're going to use those. Everyone should have this from the past. I think I was going to use it last class, but since we ran over, I didn't go through this workflow. So it should already be installed on most people's machines, but we have all these base meshes right here, and I'll pull out the bat wing, but you can pull out whichever one you want. If we come back down to the ground here, okay, so I'll have to give it some inputs to show up. So I think most of these are pretty similar. Some might have a couple more inputs than others. But at its base, they're all the same. With these meshes from Mesh Plus, the only thing they do need is a base region to be defined within. So you could use whichever one, and the only thing we'll focus on is the G0 component, which will define the base for this shape. All we really need is a rectangle to define it within. So if we just take a rectangle, it's pretty much all we need to define where this bat wing is going to be placed in the scene. So if we plug that rectangle into G0, we'll see that we now have a piece of mesh populating down here. And these meshes are quite low resolution at the moment, but it's not going to matter later when we pull in the Weaverbird plugin to actually smooth everything out at the very end. But I just baked it into Rhino to see like what it looks like. And what these pieces of mesh are is they're quite special in the way that they can tessellate off each other. So if we place all of these, say, batwing meshes next to each other, they'll perfectly tessellate, and the vertices from one side will mesh with the vertices from another side. So the whole thing will flow together. So if we made that ourselves, it'd be quite difficult to get this all to line up. But using this plugin, it's already done for us, and we can see these fun shapes pretty quickly. So just leave that out of Rhino. All we need is this green component in Grasshopper to be showing up. Okay, so
Hey, RJ.
Yeah.
I had a quick question. What plugin is used when you pulled the Batwing component out? Is that Lunchbox or?
yeah, so that's Mesh Plus, and in general, and wait, file sharing? Announcements, definitely here. So right here,
Okay,
this is
Gotcha.
the link from, I think, 2 weeks ago.
right. Okay, thank you.
Yep. Okay, so is everyone able to get that into the scene? So you do have a batwing or other type of mesh. Cool. So once we have that in, if you remember from some previous classes, I might have mentioned this, but what we're going to do now is basically replace the sphere with this new piece of mesh. We could plug in the new mesh into these inputs from before, but one little tip I'll give y'all is if we can move any input to a different input. So yeah, if we hold Control and Shift, so if we hold Control and Shift on the keyboard and then hover over one of these outputs, it'll bring up a little like reverse arrow. So if we left click on that output, we can go and it'll actually give us the two wires itself, and we can go and plug that into a different output. So I'm just going to swap it from the sphere or the center box that you had, and just move it up to the bat wing or whatever other mesh you used. And it should auto populate, and everything else should flow along. So looking back up at the curves in the scene, we've now changed them from the cube or the sphere, whatever you had before, into now we have the mesh populating the box up top. So it's a little more interesting than just a box sitting there.
What kind of mesh should we use if we don't have the?
You could just use the center box. Type that wrong. Yeah, you could use either a box or a sphere or a cone. Let's see. Yeah, there's a lot of options in the surface primitive tab.
And then I
There's also a lot of options here with different like base shapes you could use to morph into the boxes if you don't have the Mesh Plus plugin. So you could use something more interesting than a cube. You could use a cone, cylinder, sphere. We have a couple options in Grasshopper itself under surface primitive.
And so you can create your own.
Yeah, or you could create whatever you want. So you could bring in your own mesh. You could, bring in like a benchy from Thingiverse and plug that into all the twisted boxes, and it'd all be morphed really weirdly, but it look quite cool. So yeah, you can use anything, but just for right now, I'm going to use this tessellating shape. Just because it looks quite interesting in Grasshopper as the tessellated shape gets paired in this way. Okay, so hopefully everyone's to that step. If there are any questions, let me know. But should be doing good. Cool. So yeah, the next thing we'll do is now that we have 17, well, in my case, I have 17 meshes populating the morph twisted box. Just go ahead and hide everything else real quick. So now that we have the meshes, you'll see they're all separate. We have 17 separate meshes. In the next steps, I'm going to want to smooth out all these meshes so we have like a more organic structure. So we'll add more polygons in and smooth them all out. But before we do that, we'll want to join all the meshes together. So there's a component called mesh join, and that'll take the, in my case, 17, however many meshes you have. And since they're tessellating, we won't have to worry about any vertices not lining up. So we can plug the morph to twisted box into the mesh join, and the output here, we see we have one mesh with all of the previous meshes joined into one continuous loop right there. If you're working with another shape, not from Mesh Plus, you won't really have to worry about the smoothing things out, because if you're using a sphere or something, it'll already be quite smooth. But in this case, we still have a couple more steps for this one. So once it's joined together with the Weaverbird plugin, so where was that? This one. With the Weaverbird plugin, it has tools for subdividing and smoothing meshes. So if we just start typing in Weaverbird, we'll see there's this one component called Weaverbird Catmull-Clark subdivision. In the plugin itself, I don't even know if I have enough room to see it. Okay.
Is Weaverbird new?
No, so that one was posted about 2 weeks ago. I think we
Oh, I see it now.
used it in the last tutorial as well. So this one has a lot of different subdivision tools. And each one here is a different like mathematical way to subdivide. So Catmull-Clark was, I think, 2 people that wrote out this mathematical equation for subdividing and smoothing. But there's also loop subdivision, mid-edge, this other mathematician, some other stuff. But we'll just use the Catmull-Clark as this is like the most average smoothing method in CAD softwares. So if I plug the mesh join into the Catmull-Clark, I hit everything else, so we now only see the subdivision component. And we'll see the preview in Rhino is now a bunch, or a lot smoother. There's a bunch more polygons in that mesh, and everything has been like smoothed out, so there's less hard edges. So once we have this, the next half of like this tutorial is make it into a shape that is solid, watertight, that we can go ahead and 3D print if we wanted to. So basically making it a nice solid mesh. Right now, it's just like a single mesh surface. There was no thickness to any of this at the moment. And if I bake it out, we can see that a little bit better. How it is just one surface with a front and a back face kind of all swept together. So we'll add some thickness to this. I think most people here have Rhino 6. So we'll go with that. There is a tool called Quad Remesh, but I believe that's only in Rhino 7. So to substitute that, basically what we're going to do is take this mesh that we subdivided, find all the edges in this mesh, and then thicken those edges with a pipe to actually add some volume to the whole shape. We could offset the mesh, but we might run into issues of the surfaces overlapping and adding areas of zero thickness. So creating pipes from curves is a safe method to add some thickness in this case. So we can use this component called face boundaries. And this is useful for any mesh, specifically mesh types. So we can plug the mesh into the face boundaries, and we'll see it'll give us all of the edges that make up the actual mesh. It's hard to see that in Grasshopper, but when I had baked this mesh a second ago, we can see that the curves that Grasshopper is finding are these same lines in the actual mesh when we bake it out. So it's just visualizing those. But now that we visualize them, we can hover over B and we'll see that we have a whole bunch. I have over 1,000 curves that make up all these edges.
Those are like the edges with like open. And meshes.
Yeah, so you bring up a good point, because there's this other component called mesh edges.
Oh,
And what this one does is it will like diversify even more what the edges mean. So with edges with 1 degree of connection, which are only like the naked edges, we'll get the outside ones that have 2 connects or the inside. I don't think there'll be any E3s. Yeah, there's nothing in here. That's if we had like overlapping stuff. But that is another way if we wanted to maybe like cull out the outside or just the inside or something like that. Maybe add a thicker rim. We could use this, but yeah, right now we'll just stick with the face boundary because that'll just give us every edge ever,
okay.
which is super easy. We'll just do every edge. Okay, so with this, we can add that pipe. And I'm going to add a pipe in Dendro itself because that'll be the most streamlined workflow for creating this into a watertight 3D STL file. If we use the pipe from Grasshopper itself, that's a B-rep and it's open, so it's not the best workflow for this method. But in Dendro, we've used this in the past for some other things. In today's class, we're going to use the curve to volume component from Dendro. So you can also type in curve. I don't know. I always go here and click it. Curve to volume. Yeah, curve to volume is the component. Okay, so with this component, as we've used Dendro plugins in the past, they do always need settings as well to define the detail of the volume itself that we're creating. And again, we use this so that components like union work a lot better. Boolean union works a lot better in this case than if we were to do pipes with B-reps or meshes or something like that. So we'll also need this settings component as well, this create settings. Yeah, so to Jake with the question about Rhino 7, there's not really a benefit to using the quad remesh component, especially in this case where the subdivision from the mesh itself is already in quads. But if you wanted to subdivide this more into even finer quads, then you could use that. The quad remesh component might take a little more time. It's a little bit heavier as it remeshes everything, but you won't have any triangles. So if you're going for a look that's very uniform with only quads, then you could use the quad remesh component. But yeah, be careful with that one. If you add too many faces to subdivide, it might take a long time, but it is very clean. It outputs very clean geometry compared to if you were to do like a traditional remesh with triangles. That might be a little bit messier. So I do like, and make sure you add the settings to it as well, but I do like the quad remesh for very clean work. Okay, so for the settings here, The only thing we need is the voxel size, and as I usually always do, we add a slider from 0.01 to 1. In this case, if we have a very small number, that'll have a lot of detail in the final mesh, but it'll also take a lot more time to compute. So when I add this slider in, I always move it all the way up to 1, so that we start with the lowest resolution possible. So we have the quickest script possible. And then once we find kind of a sweet spot where we like, we can bring that slider down so we don't crash our computer basically as well. So I'll start with the high number here, and we'll work down in a second. But with that slider in the settings, we can plug the settings into the volume curve, which is the first input we need here. Notice also I'm going to plug in the curves last because I want to set up everything else beforehand. So it's not trying to do operations on curves when we don't have the right settings yet. So I'll copy and paste this slider again, and we'll just use this for the radius because we need a radius value as well. So once we've done that, we can finally plug in the curves from the face boundary component. And when we plug all that in, we might be seeing this error that says the radius must be at least 30% larger than the voxel size. So now that we have that all set up, we can start bringing down this voxel settings number until we see something happening in Rhino where we see that volume populating the Rhino viewport. So yeah, once we see something in Rhino, we're in a good spot. Now we can bring down the radius value because right now we're getting this very like thick structure because the radius of all of the curves is just super large compared to the size that we're modeling at the moment. So we'll bring down that radius. And question?
Yeah, it finished.
That was about it. Yeah.
Okay.
Yeah.
Mine failed because it says there's a part that could be found.
Okay, so is it like a DLL?
Yes.
Okay, yeah, so when you install the plugin into Grasshopper, if you go to like file special folders,
Right.
what either happened is you didn't add all the DLL files in with Dendro, or they weren't unblocked when you downloaded them.
Okay. So I know I unblocked them,
Mhm.
but there was only one in the Dendro file. Oh wait, I didn't do the white one.
Yeah,
I forgot about the white.
yeah, drag that one in
I
as
got
well.
I got the green one, but I forgot
Okay.
about the white one. Okay.
Yeah, usually the rule of thumb for, installing plugins is to make sure everything from the downloaded folder is in Grasshopper, except for like the read-only file is the only thing that should be left over.
I tried opening the background and it like deleted mine. Is there any other pack?
Deleted what?
Like it opened up like instructions on how to use Dendro and deleted the workflow. I had.
Like your actual Grasshopper file?
Yeah.
Okay, I'm gonna save this right now and I'll just put it in the Discord. And you can just download it because I don't think there's any way to get it back, but. Okay, should be in the Discord, so you can just work from there. Okay, so with the volume curve, now we'll want to make the radius smaller so we get a more defined shape. One thing we can do is we'll run into the same issue if the voxel size gets above 33% smaller than the radius. So one way to solve that is we can just do a simple math calculation. So we can divide the radius by 33%. And just pipe that into the settings. So we only have one slider to worry about. So the way we can do that is we could just divide the curve radius. Maybe we can, and multiplying is probably better. We can multiply by, 33% or just above it. So we can multiply that radius value by 0.34. and plug that in to the settings itself.
What's that number slider plugged into? Like the A times B?
A times B.
What is that?
That's just multiplication. So you could type in multiplication, or you could just do Shift 8 and get the little star sign, and it'll pop up.
And the sliders are from that?
Yeah, if you just type in a number, like you could type in 0.34,
Yeah.
and a slider will populate. So you could just hit enter and go from there, or you could do, 0.01 with 2 periods and a 1, and it'll bring up a slider. Yeah.
Well, then all that's not necessary.
No, you don't need this
Okay.
step I just did. You could have a slider going into the settings, and you could have a slider going into radius, and you'll just have to move them together. This is just kind of automating that process. So now the only thing we have to move is the radius, and as we move the radius down, the settings will also move down at 33% smaller, so we never run into that issue of an error being thrown. What do you plug into the settings? Did you plug
No,
zero
I know, I was moving the slider
in?
and then it gave up.
Yeah. Yeah, so you'll notice as I move my radius slider down, the little number down here will also get higher because it'll take more time to do every calculation as we get more and more detail on the settings. But it's not too long, it's still 200 milliseconds, which isn't bad. But I'm just going to move it down until I can start actually seeing a thickened pipe around each curve now. So we see that there's a little void in between the lines. So I like the pipe where it's at on my screen, but you can do any thickness you want for this. I'm just going pretty low to show higher detail on the model. So once we have the volume curve set up, what we can do now is smooth it out. And this is optional as well, but this might give you a little bit smoother curves as it transitions between other pipes. Might look a little better, up to you though. So we'll see going from the original to smoothed, changes it a little bit.
That, oh, wait a minute.
So now at this step, the only thing left to do is to convert it back to a mesh so we can export it as an STL if we're gonna work towards a 3D printing outcome. So the last thing to do is back under the convert tab in Dendro, we can convert the volume back to a mesh. So we've done all of our heavy lifting with these two components, converting to curve and smoothing it out, and actually Boolean unioning all of the curves together at the same time. So we should only be left with a single volume coming out instead of the, what was it, 1600 curves that came in. So we have one curve coming out. So we have this volume to mesh component. Again, it needs a settings to come in. So we can grab another settings block, or you can, copy and paste it from over here. The only thing about this settings is that it doesn't need any inputs. It's fine as it is, the default. And that's for any scale. So even if you're doing something a lot bigger or a lot smaller, this setting should mostly all the time just be fine enough for you. We'll plug that into settings, type the volume in. And now instead of a volume coming out, we have a mesh coming out. So we just kind of converted the state that the geometry was in.
For this one, we don't need to do the voxel size?
Not for the output,
Okay.
no. The input for voxel size, for the boundary, what does this one be? For the bandwidth and for the ISO value, they don't really matter on the export. The only thing that matters, and I'll show, this is pretty much the last part in the script, by the way. So if we bake it out, we will get a mesh. So yeah, Susan, to answer your question. So the only thing that basically matters is the adaptivity down here. Right now it's at 0.1. And you see this is kind of the detail we're getting in the final mesh. Instead of 0.1, if I was to go to 0.01, so we've gone a degree smaller. And I bake this one out.
Fine.
Yeah, and then we compare like the final polygons. We have more polygons in the top one. So, you know, I've run into this issue 3D printing before where I leave it at 0.1 and I export and print and I print something super big and I can see all the
All
polygons.
the-
So yeah, if you set it to 0.01 and if you're printing really big, you won't see the polygons as much. And you can go another degree lower,
another
even
word
more
is like more
vertices.
0.
Yeah, like another 0.001. So you'll see with this mesh, we have 130,000 vertices with the high detail, and without it, we have like 87,000
Oh,
vertices. So their faces. So that's really the only thing that matters for that. But yeah, so at this point, if we bake the final component, so we can right click on any component in Grasshopper. And if we have to right click on the icon in the middle itself, but we'll have the option to bake. So if we do bake, we can just hit OK, and we should get a mesh coming into the Rhino scene. And if we look at this mesh, the only thing that matters for 3D printing is that the shape is watertight. There's no overlapping planes, all the vertices are welded together. So what that looks like visually is we have this shape in Rhino. And if we look on the inside here, we'll see that the volume is continuous, like as it flows through the internal structure of this piece. It's a little hard to see, but unlike if you were, you know, making a model with a lot of boxes like on a grid and you try to print that, you'll have faces overlapping and things. But in this sense, the volume is single. There's a single volume and it's continuous as it goes throughout the model. So that's pretty nice. We can also see our one mesh coming out. So this workflow, you would never have any issues with 3D printing, I would say, because the Dendro plugin mostly always solves for that and always gives you a single continuous internal volume for the things that you're modeling, if you do it this way. So we could go and 3D print this right now and there would be no issues with slicing or anything. What do you make? It's pretty interesting.
in-
Just super small pipes?
No, I just changed the one
Ah,
to CLP.
cool. Yeah,
You print. I don't
in resin maybe, yeah. Yeah, so now that we have that, we'll come back to the very beginning again. We have that figure. And at this point, I'm gonna delete everything else around here. At this point, the curves are still an input to the script. So we could change the input or change some of the points on those original curves. And we give it a few seconds to recalculate every single time. And we'll be given very different outputs just with these simple changes with the script like this. So now we can really go back and rework how the curves are set, place them around the neck in a better way. You know, if you were intending to wear this, and the script will repopulate everything with every single change you make and give you completely different outputs. So quite powerful in that sense.
Would you have to rebake something when you do that?
Yeah, so that's the only thing you would have to redo. But usually I only bake when I know I'm done with everything, and I'm just gonna bake, export, print. I wouldn't do any other steps in between. So
Can you unbake something?
yeah, you can delete it from Rhino.
Okay.
Yeah, because baking, all it does is it takes the object, geometry, curve, whatever you have in Grasshopper, and it just places it in Rhino itself as like a copy of it. It's a destructible copy, so if you make any changes to it, it's going to mess up the piece of geometry. So I usually make all the changes in Grasshopper, and then when I'm happy with that, just go ahead and bake it and save it out.
Okay.
Yeah, because you can't really save anything from Grasshopper itself. Like even though we made this mesh in Grasshopper, I can't save it or export it from Grasshopper. So I have to bake it into Rhino and then export from there.
Okay.
So how's that working for everyone else? Work well? Yeah, so, I don't know, it could be a necklace, could be a building, could be a city. A spaceship. Shoot.
How did you get in that view? And then just say about it.
Oh, yeah, so if you drop down the perspective in
Oh, okay.
Rhino, you can change a lot of different things. Yeah, so Arctic's nice, it just makes everything white, no matter what color it is. Render is also cool, rendered just takes up more CPU usage on your laptop if you go into rendered, but it's not super heavy, just kind of adds a little more shadow. Maybe artistic's the heaviest one. I don't know why I clicked that. I know it's
Yeah, because it's like
there it
the
is.
pencil line.
It's kind of cool. Yeah. Yeah, but I think Arctic's the lightest one on your computer if you just want basic shadows and lighting. So that's pretty nice.
How'd you get that white and black view of it? Mine's still red. You see the color and stuff, or is that?
Oh, yeah, so I mean like in this, did you bake it out? Because
Oh,
this
yeah,
is
I
a
baked it.
mesh in Rhino.
Yeah.
So I baked it, the figure's over here. So I baked it and moved it away, just so I could see it standalone.
I see that.
You get rid of the curves once it's, like the big, has to go along, go away. How do you get curves to go away?
Yeah, so one thing you could do is select the curves themselves. You might have to click on them individually if you have the piece of mesh in its way. Or you could delete the mesh out, move the curves, and then just bake it again. Yeah, the curves are an input, so it's important that we don't make any physical changes to the curves unless we want the output to change. But what we can do with the curves is if we select them all, we can go into the curves like layer, or you can make a new layer yourself over on the right-hand side. And we can just change the curves into that layer just like we did for the mesh at the beginning of class and just hide them away. Okay, so with there only being like 30 minutes left that I wanted to go for, I don't think we'll actually build the next part, but I gave you all the file in Discord, so you could follow along if you want. But I'll go ahead and explain like just what's happening in here, so you have the understanding of the surface texturing, so you can like work on this and change it later if you want for one of your projects. So yeah, it's just the twisted box work in progress. I just added a new one to Discord. So that's this section down here. It's a little bit longer, but you know, it always takes longer to explain than it does to just build this out myself. So yeah, with this one in Rhino, I've hidden everything else. I hid the figure and the curves from the scene. So right now we just have the surface to look at. And you could work on whatever surface you want here. And there's a couple different ways to make surfaces in Rhino itself. I might bring back the person maybe and create a surface real quick. One way we can add or make surfaces is just use the loft component. So let me make something just fit onto the body here. Well, let's see something like. Okay, so we can add a couple curves into Rhino, and just as we did in the last workflow, a lot of the workflows go like this: is adding curves and then moving the control points. But I'm just gonna move these away a little bit, just so we have like a, I don't know, piece of armor or something sitting on top. Okay, so we can take these curves and we can do the same thing we did for the last workflow, which is using these curves and making a loft out of them. In this case, I guess what we can do is a little bit different. We can just use one curve component. And as I go through, it's important how you select them in Rhino, but we can select 1, 2, 3, again, in a line. So the loft flows smoothly between them. You can select 1, 2, 3. We can go to the curve, and instead of setting 1, go down another input, do set multiple. And now we'll have all 3 curves within this component. And from there, to make a surface, we could just loft those 3 together. You'll see it'll move just like that. And then instead of using that surface down there, we could use the surface we just made. And with the same input as before with Control Shift, just go ahead and move it and plug it up into there. So we have the surface solved for. The other thing for this input, as we worked on in the past too, just like with the Voronoi script, is we have a attractor point, and we can move that point on the surface to kind of change the way that the script is affected by that. So this point is in Grasshopper itself. So when we click on it, the gumball is coming up in Rhino. So the point is instanced in here. So it's not in Rhino, but we can move it in Rhino, which is kind of cool. So we can use that and pull the point around. And you'll see as we start to hover over the piece of geometry with this point, that surface will start to come out. And another little tip, I've showed this green cylinder before, how it either just shows what you click on, or if it's turned off, it shows everything in the scene. We can also use this little orange circle sphere, like orange and white, to change like what the normal and selected inputs look like. So by default, it's this translucent red, translucent green. But say I want to see, you know, this surface a little bit more high detail, instead of having the alpha transparent value down at 100, can move that up to 255. And then we actually have shadows and light bouncing off the surface, even though it's only in Rhino. It's not baked into, or it's only in Grasshopper, it's not baked into Rhino yet. Yeah. Looks interesting. So yeah, now we have a little bit more better idea of what we're actually doing with something so textural and so complex here. Okay, so I'll go back to how this is built out. We have this loft, using that as the base surface. It can be whatever surface you want. Just know it has to be a surface. So when you hover over it, it should say some sort of surface, either surface, untrimmed surface, either works. But it can't be a mesh, can't be a BREF. Those are different than surfaces here. So the reason why that matters is because this diamond panels component, which is from the Lunchbox plugin, is over here somewhere. Yeah. The Lunchbox plugin, it has a lot of uses like machine learning, and like trusses for architecture. It's kind of a does everything plugin for some reason, but I like the panel dropdown, and we have these couple different pattern options here. So right now we're just using the diamond panels, and you can see it gives us this like crosshatch pattern on the surface itself. And the reason why the surface is important is because if we think back to the very first class when we were doing the Voronoi scripting, we could reparameterize the surface and give the domain from 0 to 1 from corner to corner. So we can see that the diamond panels here are flowing based on the edges of this surface. None of them go outside, you know, every vertex is lined up with an edge here. So it's very important that it is a surface so that it knows kind of the domain of the geometry itself. So coming out of that, it has two outputs here. One is diamonds, the other is triangles. So we can see that the triangles are the outer edges of this and the diamonds are the internal structure of this. What we'll do basically with that point in the scene is we'll find what looks to be the center point of each of these cells. Where you go? And we'll find the distance between the center point and the point that we're setting. And based on what that distance is, we can use that to calculate if we're going to kind of add some texture to those cells or not. So next one, finding the center points. We can see that we've taken those internal cells, given them a center with this area component. There's also a volume component that does the same thing, but could use them interchangeably. We don't need the volume or the area. I just want the center of a 3D piece of geometry. I guess there are some other center components, but these are only for, you know, actual like flat polygons. So they're not really useful if we have a 3D surface like this where there's multi-dimensionality to it. So find those centers. Again, having the surface is important because with the surface closed point, we can find the closest point on the surface itself. So right now, they're pretty much on it. They might move slightly, but it's kind of hard to see. Kind of in this area, you can see them changing. But we're basically just projecting those center points onto the closest point on the surface itself. So now we've taken the surface and found points in reference to that surface, which is important for moving on down the line and affecting the surface. So we can take those points and, as I said, find the distance from that input point to all the other points. We can visualize that with a line. So we can go just put the same inputs from A to B. And we're basically taking this value is doing the distances, so it just gives us numbers. It doesn't visualize anything, but those numbers are the same lengths as these lines, so we can, you know, see how the relationship is built. So with those distances, I'll just bring these back up again. Could even add a, where is it? Might have lost a plugin. It's going to apply the number to each one, but that might get messy. Yeah, so, you know, imagine that one line has a length of 9.9, another one has a length of 8.8. And we can take all those lengths, and with this inclusion component, what this one's doing is it's checking to see if those distance values are within a domain that we set. So this is the domain that I've created. So it's going from 0 to the slider 7.15. So what it's basically saying is, you know, only include every distance that is super small to 7.5 units. So if we look at the overall component, we can see that it's giving true falses. Yeah, we can see that only this grouping of lines has been selected. So if we make that value smaller, you know, we're selecting less lines, and as it follows, the pattern grows smaller. So we can expand it out or in like that. So again, with the lines visualizing what this component's doing, but it's basically still just taking numbers. And if it's within the inclusion domain, it'll give it a true value. And if it's outside of the domain, it'll give it a false value. So with those, binary true and false values, we can find with this component the member index, which basically takes the set, it checks for a member, in this case, all the false values, and then we'll take those false values and replace them with a movement value of 0. So they're not going to move at all. So we have a pattern where anything outside does not get affected. And at this point, we can remap those numbers. So this is, as it says, the texture size. So we take all those distance values. We've set the ones that are too far away to be 0, so they don't move at all. But everything else still retains its original distance away from the point. So we can take those original distances and remap them. So basically taking the original domain that they exist within and adding a new domain. So if we think about like the twisted box that we just did, we have the original twisted box and then a twisted box to map to. In this sense, we have the original domain and we just want to map those numbers to a new domain. So we can see what that does with this slider. As we make it smaller, the distance domain is also smaller, so the points go back to the original locations. But as we move this bigger, the texture will also move farther away. That's just remapping those original distance values in relation to that point. And again, we're just replacing it with that original list. So the original distance value has just been changed over time. So we've added zeros for anything too far away. And then again, actually added those values from this slider into these points right here. So it's always important to keep your data structure consistent in Grasshopper. So in this case, if I just keep replacing the values I want to change in the original list, then we won't corrupt anything and everything will flow evenly. So the next part is just finding the normal vector from the surface itself. You'll notice when the points were down here on the surface, they were all moving vertically up away from the surface. And in this case, I didn't have to change anything. I just moved that point, and now the texture is now going the X direction now. It doesn't matter. The only thing that matters is that the surface, the surface itself has directionality. So any point on the surface, it has a vector pointing off of it, exactly, tangential to the surface, a normal vector. So again, since it's a surface, we can find that value based on the points that we generated up in the beginning. So these points were important also for finding a normal vector that's on the surface itself. So with that, we're getting the frames out of here, and we're also getting the normals at each of these points. So we could, again, vectors are not visible, but we can display vectors with this component here. And so we can actually see the vectors in Rhino, which we cannot see from this component. We just see the planes, that make it up. But we have the normal at UV, which we can see is defined as a vector with 3 points. So take the vector and also take the points at UV. And we can see that we can visualize how the vector is flowing. And you'll see they're all normal to their location on the surface. So, these are going more that way than the ones that were there pointing the other direction, just because of how the surface is shaped. We can probably also make the little triangles move in even more, if we change how that looks. So that'll point differently. Yeah, we could just flip it, and that's a good point. We're just doing that with a negative right here. So, I've taken those vectors, multiplied it with the offset distance, which is just from the domain here. We're just multiplying those together and then flipping it. So now we can actually visualize, what's happening with the actual texture itself.
And the vector direction is in original Grasshopper, it's not a plugin.
Right, yeah, this is all stock so far in Grasshopper. The only thing that's not was the diamond pattern. Yeah, which you could maybe make your own pattern in Grasshopper yourself. Might just take a lot more effort than a plugin. But yeah, everything after that has been stock Grasshopper. And I think the rest is, except for clearly the ending here. But yeah, so yeah, we have those vectors pointing off the surface. So we can actually use the points from the beginning here. So we had all those points, and we can just move them away based on that vector. So we kind of give them a bulge there. And with these points, what we can do now with this Delaney mesh component is what this will do is it'll do a triangulation operation on a set of points. What that basically means is we're taking that original diamond cell pattern here. And right now, each of these diamond cells has 4 boundary points, 1, 2, 3, and 4. But if we add a 5th one in the center, we can also move it out based on the vector. And then we can recompute the actual meshes. So we have polygons now going around, each of the pyramids. And if I just look at this one, we can see that we have that point moved out. And we've just added that 5th point into the system. So we make like these little, pyramid shapes there. So to do that, we have the points that we moved out, which are going to be like the ones at the end of the little pyramids here. And we have the original grid underneath. If we deconstruct the B-rep, which is what, these surfaces are, a surface is a B-rep, but a B-rep's not a surface. So we can deconstruct that and get the actual vertices out of there. And again, keeping the list intact, we can use this component to insert items into the list now. So if we come up here, we can see that, we have a separate branch for each of the quads, and each quad has 4 points to it. So we have a bunch of branches here for however many quads there are, and each of them has the 4 points. With the Delaney mesh, if we wanted to add that 5th point into the mix, we can just add that at the end of every line here. So you'll see I have a panel with the number 4 in there. And what that'll do is, we have 0, 1, 2, 3, and that's going to be the same for every, what are they called? The diamond panels in this scene. They're always going to have 4 points. So we know that if we want to add another one, we can always add it into the 4th index space, which is going to come right after 3. So if we compare the two, we've added this 4th point in to every single one. So now each branch has 5 points total. So with all those 5 points together, and with the base plane itself, which when I clicked on this earlier, we saw that, all those base planes to start the mesh, we can with that construct the new pyramids with those vectors moving the points. And then again, just to clean it all back up, we have, these are the the quads from the middle, but we also have to worry about the surfaces from the edges, which were just the little triangles. We don't have to do much to them because we're not moving them. So we can just, again, convert them to the same mesh, merge the whole thing back together. So we have the final surface. The last thing here is just the rest of the plugins. So we have Weaverbird, Pufferfish, Kangaroo, Weaverbird, and then Weaverbird again. So all this is doing is like cleaning up and making the mesh a little bit nicer if we want to export this later. So with the first one with welding, I might have mentioned this just in some of the tutorials before, but when you weld meshes together, what we're basically doing is taking the mesh itself, which I'll bake this, and we're taking this, and each of these little cells, can I ungroup? Yeah, each one of these is different, right? So we have like all these different panels on the surface. It's not a single continuous mesh, which is what we want in the end, especially if we want to smooth it out with subdivision. We'll need everything to be welded together. Yeah, because if we just smooth like each of these single ones out, then we would have like a pyramid with a rounded edge that doesn't connect to the rest of the pyramids. So with welding, we'll take, say there's 4 pyramids here, which all have a vertex at this point, and they're all like overlapping the vertices. So with the weld, we can take the mesh, and if we set welding to true, it'll take, it'll look at all the points and say any of them that are too close together, which in this case, they probably have, a distance between them of 0 or maybe 0.01 e to the -10th, like super small value. And it'll just take all those vertices and make them into one. So they're welded together. So once we have that, we have a single mesh again. So it's similar to the Dendro workflow where we go from something crazy, like a lot of things, like we have 265 to a single continuous mesh. So I'm just going to delete this. Don't need any of that. So once we did that, I brought in this Kangaroo clean component. just clean it up a little bit, make sure there's nothing weird happening. I don't know if it's changing much visually. But if we add some like flip normals or faces that weren't exactly right, actually, I think when I bake this, we can see that there are in fact some flipped normals. And the normal basically, how I have Rhino set up is we can see the back face of any surface in the color red. So we'll notice that like each surface, even though it's a 2D planar thing that has no thickness, it has a front and a back. So the front here is visualized by gray, the back here is visualized by red. We can see that we do have a few panels standing out that are not the same as everything else. So once we weld, clean, and then unify the face windings or just the way the normals are facing, we should have solved that issue. So just bake this one out as well. And we can see that, yeah, in fact, everything is now the same color on the same side. So the normals are all unified at this point. And then the last step here was just to smooth it all out. So you might like the very pointy nature of it. But it's a little unwieldy if you're going to try to print this with, you know, the volumes getting super, super tiny as you get to a point. So I just smoothed it out a little bit so we don't run into that issue as much. So we just have smoother bumps there. This can be, you know, placed on any surface with any pattern. We don't have to use the diamond panels. You could do the hex. You could make your own panels, use triangles, or anything else that you might see. But yeah, I guess we have the control over the texture size, but we also have control over, you know, how many panels are in the texture as well. Let me turn some stuff off. So we can also change the, you know, the number of the pattern and get these different things. But yeah, still makes sense. Yeah, that's the rest of that workflow. If anyone has questions, feel free, and you know, try it out on your computer as well. This script is pretty light. There's not a lot of heavy things going on, but it is a lengthier script. So yeah, 6:50. Yeah, we'll meet next week. Next week is the last class before spring break. So I think we might have someone come in to talk about some study abroad program that Jonas is doing. I don't know much about it, but that might happen. But we'll look at, next time we'll look at 3D photogrammetry, like scanning with your phone. We'll look at some VR design stuff, some sculpting in Blender, basic 3D printing, just a lot of like overview of different softwares and workflows and technologies before spring break. So you just get a view at it. And after we come back, we'll probably dive in more to the final project, which is basically just like with this necklace, creating your own interesting thing that we can 3D print out of Grasshopper, basically is the final thing. But we'll cover that more in depth next class before break kicks off. So yeah, see y'all next week.
Thank you.
Yeah, you're welcome. Thank you.